Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at factorising cubics. So what's a cubic? Well, a cubic's a type of polynomial. A polynomial just has lots of terms with x's in it, but each x term has a positive integer as the power. So here the powers are 3, 2, and 1, all positive whole numbers, and polynomials can also have constant terms as well. So a cubic is a polynomial where the highest power of x is 3. So this is a cubic because the highest power of x is 3. So we use fx notation for polynomials and other functions like this. So this just tells us that x is like the input, what we put into the equation. And so if x is the input, you cube it, minus 4 times input squared, minus 7 times input, plus 10, and so on. So we need to know this because we need to use the factor theorem, which says that x minus a will be a factor of this polynomial if and only if f of a is equal to 0. So what does that actually mean? Well, let's have a look at calculating, for example, f of 2. So f of 2 just means I take this equation and I replace x with 2. So I've just replaced each x here with 2. Now, if you put that on your calculator, you get negative 12. So f of 2 is equal to negative 12. And what that means is x minus 2 is not a factor. So how do you come up with factors? Well, it requires a bit of trial and error. What you do is you try positive and negative factors of the constant term. So in order to find a factor, I need to choose positive, negative factors of 10, and I need to use trial and error to see which one of them I can substitute for x to make this equal 0. So it turns out if I try 5, which is also a factor of 10, if I substitute x for 5 and then put this in my calculator, I get 0. So what that means is x minus 5 is a factor. It means that I will be able to multiply x minus 5 by some polynomial to get my original cubic f of x. So how do I find this polynomial? How do I find what I need to multiply x minus 5 by to get fx? Well, after you've got this factor, to find this polynomial, you use polynomial long division or synthetic division. So I will now show you those. So we know here that x minus 5 is a factor. So we want really to see how x minus 5 goes into our polynomial x cubed minus 4x squared minus 7x plus 10. So this is how you do polynomial long division. Now you start by going the first term, the leading term, into leading term. How many times does x go into x cubed? Or if you like, x cubed divided by x. So x cubed divided by x is x squared. So when you get a term up here, you need to multiply it by this. So we go x squared times x squared times minus 5. So then what we're doing is calculating the remainder at each step. So x cubed minus x cubed is 0, negative 4x squared minus 5x squared. So that becomes a plus, and you're just left with 1x squared. So when you've got a remainder, you divide it by the leading term. So x squared divided by x is just x. Okay, we're going to repeat the process. So we're going to bring down this minus 7x to help us calculate the remainder. So x times x is x squared. X times negative 5 is negative 5x. Once again, you calculate the remainder by subtracting. So negative 7 minus 5x is negative 2x. So I'm left with this. Okay, bring down the 10. So now when I get a number up here, I need to multiply it by this. So I go negative 2 times x, negative 2 times negative 5. So here, if I subtract this, I get a final remainder of 0. And that's what I expected, that there would be no remainder because this was a factor. So what have I actually found? So I found this original cubic fx is equal to x minus 5 multiplied by my answer up here, x squared plus x minus 2. So x squared plus x minus 2 is also a polynomial. It's a quadratic. Quadratics are polynomials. So I know how to factorize this. I can factorize it simply. Find two numbers that multiply to -2 and add to 1. So if I leave my x minus 5 alone, the two numbers that multiply to -2 and add to 1 are 2 and -1. So I have fully factorized this cubic. I've written it as 3 linear factors multiplied together. All right, so that's my final answer here that I obtained by using polynomial long division. I know it's a very long process, so what you need to do is you need to try factors of this number here to come up with a root, to come up with a number that when substituted for x makes this 0. When you found which number you can input and get 0 as your output, x minus that number is a factor. So 5 is a root, x minus 5 is a factor. You then use polynomial long division so you can find what you multiply x minus 5 by, and then you can factor this as normal. Okay, it is a long process. This time we use polynomial long division, but in the next example, we will use synthetic division. So let's say we've got fx equals x cubed minus 6x squared plus 12x minus 8. We are going to factorize this polynomial. So to factorize the polynomial, we have to find a root, a number we can substitute for x to make this 0. So remember, you always try factors, positive and negative, of this constant term. So for example, you might try 4 as a factor. So if I substitute x for 4, if I put this on my calculator, I get 8. So x minus 4 is not a factor. But if I try another factor of -8 like 2, I get 2 cubed minus 6 times 2 squared plus 12 times 2 minus 8. I actually get 0 because it becomes 8 minus 24 plus 24 minus 8. So f of 2 equals 0. That means x minus 2 is a factor. So because x minus 2 is a factor, that means I can multiply it by something, another polynomial, to get fx. That's what factor means. Like 4 is a factor of 36 because you can multiply 4 by 9 to get 36. 7 is not a factor of 36 because you can't multiply 7 by a whole number to get 36. So we want to find this one here. We need to find this polynomial. So for that, you use polynomial long division, which we used previous slide, or you can use synthetic division. So I'm going to use synthetic division here because people tend to find it easier. Firstly, because you end up adding remainders instead of subtracting, and secondly, you don't actually have to write all of the x's. So this is how you do synthetic division. What you do is you write out the coefficients of your original polynomial fx. So this is just the coefficients here. So this was representing 1x cubed minus 6x squared plus 12x minus 8. So here you write the root that you found, the number that makes the polynomial equal 0. So that's 2. So this is the process we follow. Bring down the first one and just write a 1. So what you do is you times this number here by the numbers you bring down. So 2 times 1 is 2, and we put that number up here. So now to calculate the remainder in synthetic division, you actually add. So -6 plus 2 is -4. So when you get a number down here, you multiply by that. So I go 2 times -4, and that gives me -8. That goes up there. So now to calculate the remainder, we add. So 12 plus -8 this time gives you +4. And then we do this one last time to calculate the remainder of the whole lot. 2 times 4 is equal to +8. So that goes here. -8 plus 8 equals 0. So when you're doing synthetic division, just note this last number is the remainder of the whole division. These are the coefficients of your polynomial. See, we know that when I divide this cubic by a linear factor, this is going to be a quadratic. I need an x squared term there because x times x squared gives x cubed. So this will have three terms, x squared, x, and constant, and they are determined by these numbers here. So it's going to be 1x squared minus 4x plus 4. So if you multiply this by this using FOIL, using expansion, you will get our original polynomial there. So just be aware, even though these were coefficients of x cubed, x squared, x, and constant, the polynomial you get as the answer has a lower power of x. So because this was an x cubed, our answer is going to be x squared. So this is going to be the coefficient of x squared. It means this will be the coefficient of x. This will be the constant. And this is the remainder of the whole division. And we should get 0 because x minus 2 was a factor. When you divide a number by a factor, you get 0 remainder. So what we figured out is that fx is equal to the product of these two polynomials. Now I can factorize this one easily because I can just find two numbers that multiply to positive 4 and add to negative 4. So we end up getting x minus 2 times x minus 2. The two numbers that multiply to positive 4 and add to negative 4 are negative 2 and negative 2. So this one factorizes to x minus 2 squared. It turns out fx is actually x minus 2 cubed. So x minus 2 times x minus 2 squared is x minus 2 cubed. So if you expand this, you will get this. And that's my final answer. I have factorized this polynomial. So it doesn't matter whether you use polynomial long division or synthetic division. A lot of people find synthetic division much easier. Whichever way, we follow the same process. We find the first factor by trying factors of the constant term and seeing which of them makes the polynomial, the cubic, equals 0. If a number a is a root, then x minus a is a factor. You divide this polynomial by x minus a, either using polynomial long division or synthetic division. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.